Hello everyone, welcome to Pepcoding. So in this video, we are going to discuss the data structure Trie. So basically we'll be implementing Trie and its some of the functionalities, some of the functions of Trie. So suppose we are given, we have to store some strings, like we have to store. So we are first dealing with the function is insert. Suppose we have to insert the string A, B, C, D. Okay, so this is Trie. Suppose this is a data structure and we are inserting a string in it. So we have inserted A, B, C, D. So if we'll check for A, B, C, D, then search A, B, C, D. So this will return true. Why this will return true? Because this string is present over here. So now we are searching for another string, that is A, B, C, D, E. So will this return true? No, this will return false. Why? Because no such string ABCD is present in the data structure. So now if we'll insert ABCD E. Okay, so this will get inserted. So this will so now again if we'll search for ABCDE, so this will return true. Why? Because in this ABCDE is present. Now, so till now we have seen two functions, insert and search. Now there is one more function. If we'll search for function starts with, and if we'll give some of the letters, starting letters of a string, then it will search for such a string which is starting with ABC. So is there any string present in this? Yes, there is. Basically there are two such strings, but it will check for at least one. If it receive at least one, then it will simply return true. So there is a string present which is starting with, so this is starts with true. So this will return true because there is at least one string present which starts with ABC. Now if we'll check for starts with CD, so will this return true? No, this will not return true. Why? Because there are strings which are which contains CD, but doesn't starts with CD. So this will return false. Now let us take some other case. Like we have this case, to insert apple, and then so the apple will get inserted. The string apple will get inserted. Now it will search for apple. Is apple present? Yes, so this will return true. Now search for app. Is app present? See, apple is present, but a separate string app is not present. So this will return false. Now it will search for starts with app. So is there any string present which starts with app? Yes, it is present. So it will return true. Now inserting app. So this will insert app. Now search for app. See, previously when we searched for app, there was no such a string present. So it returned false. But this time we have firstly inserted apps, then we are searching for app. So it will return true. So like this, it will give such outputs. Now, see, if we'll talk about the searching mechanism behind any normal data structure, then what happens? See, if we have inserted apple, so apple will get inserted. Now, if we are searching for apple, so it will check character by character. Apple, is apple present? If it is completely present, then it will return true. And now if we'll search for app, so searching for app, it will search, but there is another string. Firstly, it will check character. It is ending after app and it is continuing after app. So this will return false. And if we'll check for starts with app, it will check for starts with app and it will return true. Suppose for this example, we have inserted A, B, C, D. It has checked for A, B, C, D. So it returned true because it was present. Now again it searched for A, B, C, D, E. So A, B, C, D, E was not present, so it returned false. Now again A, B, C, D, E is inserted. So it searched for A, B, C, D, E. So it was present. So it returned true. Now it searched for starts with A, B, C, D. A, B, C, sorry. So it searched for such a string which starts with A, B, C. So it found at least once. So it returned true. Now it checked for CD. So there was no string starting from CD. So it returned false. See, if we are searching in both these functions, we are basically searching. So if we are searching for any string, suppose that string is of length L and there are suppose present C, D, E, E, A, B, Z, Z, C, D, Z. Suppose there are n number of strings. So for searching mechanism, it will check how many times? It will check L into n times, which is quite large number. So what this trie does, trie basically works on tree data structure. It is somewhat similar to tree data structure. Now this trie improves the mechanism of searching. How? See, for normal data structure, for searching we have to make checks for L into n times. But in trie, if there are any strings, basically in trie, if we are searching for the string of length L, then we have to search for only L times. So we have to search only for L times. If we are searching for A, B, C, D, E, then we have to search for 5 times only. Means for A, for B, for C, for D, for E. So comparing to this numbering, this is quite small. So take some other example. And now we'll see basically how data is inserted in trie. So as I told you, it works on the mechanism of tree, somewhat similar to trees data structure. So how it is similar? Let's see over here. Firstly, we are talking about insert function. So basically how the values will get inserted. So firstly, what will be present? A root value will be present. A root is present. And if we have to insert this string car, so how? Basically, in each string, each letter is treated as a separate node, like in trees. So root, and it is having C, and then it is having A, and then it is having R. And after R, there is no letter present. So we also need to end it. So we will have some boolean that will mark it as ending point. Okay. So now other string is card. So while inserting, see, we'll first check from the root, is C present? So C is present. So for inserting card string, we'll not insert C. We'll move forward. We'll see if A is present. So A is also present. So we'll move further. Is R present? So we will move further. So is D present? So D is not present. After R, D is not present. So we will add D. And after D, there is no letter. So we will mark ending point. Now similarly for the cards, C is present, A is present, R is present, D is present, S is not present. So we will add S, will mark the ending point. For cot, C is present, O is not present. So we will add O. And after O, so we will add O, and after O, T. So T is not present, we will add T. And now after adding T, there is no letter present. So we will mark as ending point. Now C is present, we will check from the root. C is present, O is present, T is not present. Sorry, T is also present, S is not present. So we will add S and we will mark as ending point. After S, there is no letter. Now for adding trie, C is present, T is not present. C. For adding trie, we will check for T from the root. T is not present. So we will add T. Now we will add R. So we'll add R. Now we'll add I. Now we will add E. So after adding E, there is no letter present. So we'll mark as ending. Now we'll insert tried. So TRIE is present. We'll add D in this. After D, there is no letter present. So we'll mark as ending point. Now we'll add tries. So TRIE is present. We'll add S. So after S, there is no letter present. So we'll mark as ending. Now TR is present. We'll add Y. After Y, there is no letter present. We'll mark as ending point. So this is how our trie will look like. Okay. So now basically we'll see the searching mechanism behind this. How? See, if we are supposed to search a string or a word called, then how is this will work? See, from root it will search for firstly for C. It will search for C. If C is present, then okay, now it will search for O. From C it will search for O. So O is present. Now from O it will search for R. So it will search for R, but there is no R present after O. So from here it will return false. So this is how it is working. So this we have seen for search operation. Search operation. Search operation basically it was finding for the chord, and from O there was no R present. Suppose if we take a word like now if we take a word like try, TRI. So if we are searching for try, then what it will do? It will start from root. So it will search for T. T is present. Now it will search for R. R is present. Now it will search for I. I is present. So it should return true because TRI is present. It should return true? No. It will return false. Why? Because search operation while finding for a word after ending after ending letter it will search for the ending point also, but after TRI there is no ending point. There is again a node present of E, so it should also have a ending point. For search operation it needs a ending point, so I am writing here search operation needs ending point for successful search. Now talking about another search operation which was starts with. So if we are searching for a word which starts with, suppose tr, tr. Then what it will do? Firstly, it will search for T. Okay, T is present. Now it will search for R. Okay, R is present. Now after R, this starts with function don't need any ending point. Not needed ending point. So as soon as we'll reach this R, then it won't search for anything. Now from here, if it has found T and R, then from here it will return true. Okay. So basically starts with and search operation are basically search operations only, but for searching we need the ending point at last, but in starts with we don't need ending point. Suppose we are searching for a word TIE. Suppose this is the function, it starts with TIE. So we'll search for T. T is present. Okay, now we'll search for I. So there is no I present. So it will return false. Okay, now we'll see the mechanism behind this insert function. How this insert function works in our try. So what we'll do, we'll create a class of C. If you can recall of generic tree, then in generic tree we were creating class of nodes, and what it was containing? It was containing an array list of childs. And similarly for binary tree, we were creating the class of nodes, and it was having left and right. So it was having two children, so it was pointing to left and right. So for now, for tries, what we'll do, we'll create a class of try or node, whatever you want, and we will keep an array or vector of size 26. Suppose this is childs of size 26, and it will contain, why 26? Because we have 26 letters which will mark the indexing from 0 to 25. 0 will point to A or small a, or 1 will point to B or small b, and like this from A to Z, and a boolean which will mark as end, which will mark this ending point. So at every node we have 26. We can have any of this letter between A to Z. So we are creating an array of 26. So let us see the creation. So initially what we'll do, we'll mark this root point, and from here if we are inserting this for car, so we will create an array or vector, and it will have indexing from 0 to 25, and 0 will point to A, B, C, and this one is Z, and initially everything will be having null, pointing to node, it will be having null initially. And if we are supposed to insert the word car, so firstly we will point to this node of C, this node of C. So we will mark this C position, that is at index 2. We will create this node C. At index 2 we are creating node for this C. So we will add this C. Now for inserting car, again there will be, so C. So at here we were having 26 option, that is 0 to 25. It was pointing to A, B and C. So initially everything was null. Now we created at index 2 node for C. So for C, we have created. Now for again, we have 26 options, 0 to 25. Now we will again search for A. If A is not null, see, initially everything will be null. If A is not null, then we will insert A. Suppose A is present, it means it was not null. So here it is not null. And here A will become not null. And the node for A will be created. Now again for R, there will be 26 options. Suppose this is pointing to R. So this is not null and all other things are null. So it will attach R. Now at R, this is ending point. So, R will get its is end point. So this is end point is marked. Now we are supposed to insert this word card. So it will search for C. If C is null, then it will attach C. But here C is not null because we have already attached this C. So this is not null. If it is not null, it will simply move forward. Now it will search for A. For inserting A, from C it will search for A. A is also not null, so it will not add A node. Now it will search for R. Here also R is not null. R is not null, so it will not attach, it will not create node R. It will simply move forward. Now it will search for D. Is D present? So D is not present. So here what will happen at D index? The index of D, it will be marked not null. So now D will get attached. Now here again 26 options. So card, after D there is no option, so we will attach is end. Okay. Now for cards, again we will search for C, A, R, which are D. At D, S is marked as not null. Till here D was marked not null, so it was moving forward from A to R, from R to D. Now at D point it will check for S. So at S position it was marked not null. So it was initially it was null. Everything was null. Now for adding S, it was marked not null and S was created. Node S was created, and at S also it is ending point, so it will marked as ending point. For similarly for adding quote also, searching for C, then it is present. Then here also there are 26 options. So for searching for O, so A is not null, else everything is null. So searching for O will be null over here. So here O will be marked as not null and O will get attached to here. So at this point A is marked as not null and O is marked as not null. Okay. So this is how the elements will get inserted. Now we will implement all these functions which we have discussed. Insert, search, and starts with in our code. So let's move to our code section. So we will be working on these four functions: try, insert, search, and starts with. So in try function, we will be basically initializing our try object for class try. So we have created class try and we'll create its object in this function. So let's start. So inside this class, we'll create a class node, or we'll be implementing try. So this class will be private class. Can't be accessed from anywhere else. So we'll be creating array of node type to store the children. And boolean is end to mark the ending point. So now we will create constructor. So we'll be initializing the values of child's array. So this child's will be of size 26. We were having the alphabets 26 A to Z, so we have created of size 26. So now our next step is we will be initializing our created data structure. So this will be, so firstly what we'll do, we'll create a root variable of node data type, and this will be, we'll use final keyword because we won't be changing its value and it can't be accessed from anywhere else. So final private, and inside this we'll initialize. So till now what we have done, basically, see, till now we have, so we have created a root, and this root is having a child array. This root is having a child array of size 26. So this will be 0 to 25, and these are initialized with null. So till now we have done this thing. Till here we have, and this is pointing to root. So our next step is we'll be working on this function insert. So firstly we'll create a node current, and this will be storing the root. So now we will be extracting the characters in this word. So we'll start loop from 0 to length of word. So length so extracting the character from this word. Now what we'll check? We'll check if this character, see, this is the character. Suppose we want to insert car. So what we are doing, at index of C, what will be the index of C? C. This is C. If we subtract A from C, so this will give index. Suppose the difference between the code of C and code of A will be 2. See that, suppose the code of A is something and suppose the code of C is something, then C minus A, difference of them will be 2. Suppose the code of A is something and code of A is something, so difference between code of A and code of A will be 0. So if we are creating an array, then 0 is pointing to A, B is pointing to, B is pointing to 1, and for C it is 2. So this is how we'll check the indexes. So at this level we'll check if condition, if this current is having root, if this current's childs at index, whatever this character is minus character A, this character A. So this is character minus character A. So at this index we'll check whether it is null or not. If this is null, it means we'll be creating a node. If at C index, means at 2 index, there is null, it means at this position C, at index C, there is no node present. So we will create a node C. For inserting, we'll create a node C, and we will while creating at this C, this null value will become not null. So we have created a C over here. So if this is not if this is equals to null, then we will add a new node at its index. So at this index, we'll be creating a new node. And now this current will be pointing to, previously current was pointing to this, now the current will point to this C. So change the current. So current will be equals to so now after inserting all the nodes, suppose the word was car. So C is inserted. Now again current is pointing to C. Now again I will be incremented. I will become 1. Here I was 0. Now I will become 1. So for 1 character is A. Now at C it will be checked at 0, 1, 2 till 25. Is character A is null. So this will be true. At A it is null. So at 0th position a new node will be created. So this will become not null. So this will become not null at 0th position. And here a new node A will be created. And now after creating new node, current will be pointing to current dot child at index A minus A, that is 0. So it will be pointing to this. Now for R, what will happen? I value will get incremented. So I will become 2. So word dot caret 2 is R. So it will check at this position. It will check at this position whether its child, means whatever will be the index of R, means R minus A, whatever it is the index, at this index of R, the value will become not null. Previously it was null. So we will come inside this if condition. Now R node will be created and this R is created. Now current will point to R. So now after creating R, what will happen? I will become 3. Here condition will get false. 3 is less than 3. Condition false, will come out of this for loop. While coming out of this for loop, we'll be also updating our what is end. We'll be marking our is end. That means we have completed our whole word. So at this, what will happen? We will mark our is end. So is end will become true over here. So for marking true, so at this position, this is becoming true. So is end has become true over here. So this is all about our insert function. We have seen the dry run also side by side. Now we will let us add some more elements in our try. So suppose it is next word is aunt. So we will add n, we will add d. So this is this. Now suppose the other word is try. So this is here was the aunt, here is try, this is marked as ending point. So this is marked as ending point. Now we'll be working on this search function. How this search function works. So firstly we will have our current node. So have our current node. We'll start our loop for checking. Means we are searching for the string. So character wise character we'll search, or we can say node by node. So we'll iterate till word dot length. This will be I plus plus. Extracting the character. Caret I. So now we'll check the condition. If current dot childs at which index? It's whatever character. See, this thing we have discussed over here also. This about this index. So we'll write this ch minus a index. So at this index we'll check if this is equals to null. It means that character is not present. If at that particular index, if we are searching, see what we were doing while inserting. While inserting, we were making that index as not null. And while searching, if we found that index as null, it means we haven't created the node of it. Means such a character is not present at that index. So in such case, we'll return false. Means that at that index such letter, such character is not present. So we'll return from false from here only. So our next step is we'll be pointing our current to current dot childs. So this is childs. At index ch minus a. And at last, after finishing this for loop, what we'll be returning? We'll be returning whatever is stored in current dot is end. So see, what is the importance of this? Why we are not returning true from here? So this thing you will get with a short example, like the word is try, T-R-I, and we are searching for the word TR. Search TR. So in this case, if we are searching for TR, then what will happen? This is 0th index, this is 1 index, and we have passed this word. So this is word. And for int I equals to 0, ch will have t. Now we will check at current dot childs at ch minus a. That is at index t, at the index of t. We will check there is not null value. Since the node is created, it means here is not null. So if current dot child at this index is null, then we'll return false, but there is not null value, then we'll come at this position. So we are not trapped in this if condition. We'll update our current. Now our current will become current dot child ch minus a. That is a current is pointing to this. Initially current was pointing to root, that is root was this. Now current is pointing to t. Now at this position we'll again come to this for loop, and I will be updated to 1. Now I is 1, so ch is pointing to r. So now we'll check if current dot child ch minus a not is equals to null. So will this be null? Since our node is attached to t, this not had been null. This has been not null. So we'll check this condition. So this will become false. So we'll just update our current. So current will point to now r. So right now current is pointing to r. Now what will happen? I will again come in for loop. I will be updated to 2. So now we have searched for r. That means now our word length is finished. So we'll come out of this for loop and we'll be returning what? We'll be returning current dot is end. That means this current dot is end. See, wherever we have marked this ending point, at this is end value has become true. While we were inserting, is end value was true. So here it is true. Elsewhere, else everywhere, it is marked as false. Is end value is false. So at current is pointing to R, then is end value at this current is false. So it will return false. If we have, suppose if we have searched for TRI, it means TRI means I has been pointing to current, and current dot is end at that time, current dot is end has been pointing to true. So it would have returned true if we have searched for TRI. But now we are searching for TR, and for TR current has pointed till the point we were inside this for loop. Current was pointing to R and the is end value at R was false. So this has returned false. This is how we are implementing our search function. So now let us remove these things. So now we'll be working on our next function, that is starts with. So starts with function is very much similar to search function. You can easily relate. See, firstly, we'll have our current. We'll be iterating in our word. Same steps till this prefix dot length. So now we'll be extracting each word, each character, sorry. So prefix dot caret I. So now we'll be checking the same condition. If current dot childs ch minus a equals to null, it means that at such index such a character is not present. So we'll return false. Return false from here only. And also we'll be updating our current. So current will point to current dot childs at index ch minus a. And at last we'll be returning false. Sorry, at last we'll be returning true. So this is the only difference in search and starts with function. How this will work? See, suppose we are searching for the word starts with, for prefix is given suppose TR. So as I have told you earlier also, for starts with there is no need of ending point. So what will happen? Suppose this is the prefix, this in index 0, index 1. So for ch, firstly it will receive at index 0, so this will point to T. So at this point we'll search for currents. Current is pointing to root. So current dot childs at ch minus a means at this position at index T it would have been not null. So it will search whether current dot childs at index of T is equals to null. So it is not null. So it won't get trapped into this if condition. Simply current will be pointing to now T. So again I will be incremented. I is becoming now 1. So 1 is pointing to R. So this will be R and it will check. Now at T, at current of T, it will check whether at R index it will be not null because R is attached to T. So it will check again for if condition. So this condition will become false because it is not null. So now current will get updated and current will be pointing to R. Now what will happen? It will come to 2, and at this condition it will become false. This condition will become false, will come out of for loop. And till now we have, it means we have found our tr. Suppose there has not been any I. Then also searching for prefix tr would have returned true. No matter there is only tr present. Suppose there has been only t and r. Then also if we have given the prefix tr, this would have returned true. Similarly, if there is tri and this is the ending point, then also if there had been more elements like e, s, then also it doesn't matter whether there are still more nodes attached to r or not. From till we have reached our word till r, it means we have something starting with tr. So at last it will return true. If there had not been any element present out of this, then this would have returned false from here only. Okay, I hope you have understood this thing. Now we will be running our code. So it is accepted. Let's submit it to see whether all the test cases are passed. So it is working fine. All the test cases are passed. I hope you have understood the question and the implementation of trie. So thank you for watching. We will be meeting another video with another concept.